Today, we will be talking about the ICT part in connection with sustainability. So earlier this week, we talked about what the roots of sustainability are and what the history of sustainability is. So today, we'll dive a little deeper into the technology connection. And for that, I have a little outline for you. So we'll start with what is ICT in the first place? How does that connect to sustainability? Heard about these terms, reduce, reuse, recycle? Probably yes, so we'll just briefly revisit that. Then we'll talk about e-waste for a moment and about planned obsolescence. Who of you has heard that term? Oh, okay, that'll be an interesting one. And then we'll talk about a couple of pathways towards the solution. So what does decoupling mean? Materials from services. What does substitution mean? What does dematerialization mean? And how can we use those principles to get to a more sustainable use of technology? And how can technology help us to be more sustainable in our use of resources around the world? Now to start with, what is ICT? Short for Information and Communication Technology. I found out after I came here and used the term a couple of times, people gave me blank stares, and not meaning students that I exposed to the topic for the first time, but also colleagues who have been in the field for a long term, and they're like, what is this ICT thing? And when I translated that for them, they're like, yeah, we don't use that, we just call it IT. So, for the sake of simplicity, IT and ICT, same thing. If you ever end up moving to Europe or going to a conference there, and they talk about ICT, now you know what they mean. They just threw the communication in the middle. Yeah, so that's all we need to know on that one. You're fairly familiar with that. Now, why ICT and sustainability? The person, to the best of my knowledge, who first started looking at that was Lawrence Hilty. Lawrence Hilty is a professor at the University of Zurich, and he was the first one who did research in that area in Europe. So when I finished my PhD, or was close to finishing my PhD at the Technical University of Munich, I started looking around into who is doing sustainability research. And he was the first person who had an entire research group on sustainability and informatics. Like, okay, that is really cool. So I started reading up on a stack of things. I was reading so many papers. I read the Brundtland report for the first time. And I got all excited about this. And then I put together a presentation of my research ideas. And then I had an invitation to go to Zurich because I have a colleague who I've been working with for a while. His name is Norbert Seif, and he at the time was at the same university doing PhD. And he said, hey, why don't you come over and visit us for a while? And you could give a lecture here, and then you can also talk to Lawrence Hilty because he's in the same place with this research group. So we said, all right, we'll do that. And then I came to Zurich, I gave my presentation in front of this professor who I was super excited to meet and who had never seen in my life. And we talked, and when you look at me after, he's like, this person stuff, I think we need to talk about a few things. So I went to his office, and then he was taking me out on a couple of things of my research where I was just been wrong, or whether I didn't look where I didn't look enough, where I had missed some pieces. And at the end, he looked at me with a lot of empathy. It's like, I don't want to demotivate you. I think it's great when you work in that field. I just need to point out the things where you were wrong. And I looked back at him. I was like, yeah, that's okay. That's what I came here for. If I got everything right within my first 3 months, probably wouldn't be researched. He was a bit surprised by that. He's like, oh, okay, cool. All right, let's get to work then. And so that's what we did. So he has been one of my mentors over the past almost 10 years. He has a very thorough understanding of sustainability. And like I said, he was kind of the father of how can we use computer science to help us make this human lifestyle on the planet more sustainable. So we'll be talking quite a bit about his work today. So he looked into how can we harness ICT, the benefits of it. And that means two aspects. First of all, we know that our technology has its own footprint. So we gotta make sure we stop the growth of that footprint by making IT itself more sustainable. We often call that green IT. And the other part is how can we apply ICT as an enabler in order to reduce the footprint of what we produce and what we consume in our society? So both of those two aspects. First of all, make IT greener, and then make the use of IT better for our human lifestyle. I may have to switch off this camera because the feedback is probably really annoying. Let's just leave that one. So, definitions. Sustainable use is the first one. If we want to make sustainable use of a system with regard to a specific function, then look at a time horizon. This sentence is getting really long, in a way that does not compromise to use the system to fulfill that function for a given time horizon. So while the sentence is a little bit convoluted, it means we're going to look at a period of time and we want to make sure that the system that we're using can maintain its function. So it's this very, very basic definition of sustainability. It's the very root of, we want to keep this working for long enough. Then the sustainable development definition is the one that we saw on Monday. That's the one that says meets the needs of the present without compromising future generations in meeting their own needs. And then the third definition that we will come across a few times is sustainability indicator. Because we already said last time, well, it's good if we have a couple of criteria of this is what we need to be sustainable, but then how can we assess at some point whether we've reached that, whether we are being sustainable? So a sustainability indicator is then a measure that we use in a process of governance to identify actions that would help us be more sustainable. So we can understand sustainability either as a sustainable use or as sustainable development. The most of the indicators that we can find are either resource oriented, like how much cadmium do we still have left in the earth? We don't know exactly, but we have a rough estimate. And others are well-being indicators. How happy are people in this classroom this morning? Some of you are still looking a bit sleepy. I can get a smile of some out of you. Okay. So those three definitions of what we're going to be using: sustainable use, sustainable development, and sustainability indicator. Now, we're going to leave Lawrence Hilty's work for a moment and visit one of my other friends. His name is Samuel Mann. He's a professor at Otago Polytechnic in New Zealand. And he's been looking a lot at greenhouse gas emissions. One definition that he likes to use for sustainability that I find pretty beneficial for the idea of how can we use IT to make human lifestyle better is that sustainability is ethics expanded in space and time. We haven't come across the term of ethics yet in this course, so this is the first time today. And the reason why it's so important is it makes us look beyond our own needs. So we talked last time about how do I find that balance in between my own needs and wishes and in between others, like societies and the planet's needs in order to be able to thrive long term. And one of the concepts that helps us establish that balance is ethics. So ethics talks a lot about what is okay for a human to do and what is not okay. We have ethics in different areas of our lives. As a researcher, we have research ethics. As a professional in whatever discipline, we have professional ethics. Do you know any code of ethics in your maybe future field of work? Because at least two of you should, because I know we did it in 491. So there's, in the field of computing, we have the ACM code of ethics. And that code of ethics is something that computing professionals want to adhere to. It states principles like we don't want to do harm to other individuals. There was a rework last year that caused quite a bit of discussion around this harm, intended harm, no harm, like what's the right thing? Because sometimes somebody's gonna be exposed to harm to save a bunch of others, and how do I then balance that out? That is a question of ethics again. So even a code of ethics does not give us the answers to everything, but it gives us further guidelines that we can think along of. Well, but apart from relying on ethics and on his definition, Sam also looked a lot at greenhouse gas pollution. And so we see Europe's not doing that great. North America is not exactly doing great. And then we have Middle East and North Africa, South America, Central America, and the Caribbean. It goes further down. Asia, that just got combined into one big block, and then Sub-Saharan Africa. They have a lot less pollution, a lot less gas emissions because they own a lot less technology, and therefore, despite it being a pretty big continent, they have way less emissions. Now, it's not only CO2. There's also other stuff that we blow up in the air. If we talk about resource use in general, then we see a big discrepancy in between industrialized and non-industrialized countries. This one is based on a study from of Weizsäcker, which is by now more than 20 years old, so you can imagine that potentially our resource use has only ever increased. Now, we see energy is a large part of that, but cement is also pretty big, 430 kilogram. How many pounds is a kilogram?
2.2.
Yep. Okay, so 2.2 pounds is 1 kilogram. That means we're almost at 1,000 kilograms of cement per capita, per head in a country. 50 pounds of aluminum, and a lot of steel. So there are many more resources that we could list here, but the big point of this slide is to just show us that in the developing world, that resource consumption is way less. And therefore, as we know that the developing countries are trying to get to an equal standard of living and quality of life, we know this planet is going to fall apart if all of the people over here also start consuming that much. They also ask us, wait, like, does that mean like you get to have it and we don't? Like, that's ridiculous. Yes, it is. So we need to find significant ways of reducing our consumption while allowing people in developing countries to catch up with the standard of living and what they would like to have in their lives. So the problem is, how do we balance that out? How do we achieve that? And the answer is not by pulling more stuff out of the earth. So here we see one chart of where we extract resources from the earth. We have biomass down here, then construction minerals, fossil energy carriers, and ores and industrial minerals. So all of that has ever been increasing. And we can extrapolate the curve to 2020 because we're only 1 year from that. And the GDP has increased tremendously. Now from Monday, from talking about limits to growth and finite amount of resources, we cannot grow forever, that very simple quotation, that very simple formula, we know that that can also not continue in the way how those curves have been looking up. But that's only one side of the equation. The other question is, what are we doing with the stuff that we're getting rid of? And we're not very good at that either. So granted, there are some recycling plants that are technologically really advanced. And I could also show you some very beautiful pictures of how well things can get recycled. The problem is in comparison to what we don't recycle well or not at all, that's a very minimal amount down here. So here we see a lady in India who is trying to scrape some of the metals of old computer hardware. And then over here we have trash just simply being burned. Some kind of recycling collection over here. And then up here there's some more trying to pull apart hardware to be able to recycle parts of it. And we know at the rate that we're creating e-waste, it's going to be impossible to recycle all of that, even if we were to figure out how to do it really well. And the problem with doing it really well is that it is very costly. It's super costly. So the question is, what can we do? These pictures are also 10 years old, so I know that there are pretty large plantations by now for like both bad examples and good examples, but the problem itself hasn't changed. The problem itself is still that. Now what we had as our, what I like to call the old hopes, is the reduce, reuse, recycle. The problem with recycling is it's usually downcycling. Like when we have some pretty paper that we got out of the printer, the professor printed some very important assignment sheets for you, and you afterwards recycle them, and that paper gets recycled. What does it get recycled into? Where do you get the recycled paper? Where did you get it back? Which products do you use that contain recycled paper? Yes, Brian.
Well, usually whichever has the recycle symbol on their logo or on their product.
Right, so we usually can tell by a recycle symbol on products, but what are example products for that?
Maybe like brown bags that you get.
Yep, brown bags that you get at the store. What else?
The cup holders at like coffee shops.
Cup holders at coffee shops, yes. What about brochures and like magazines and yes, no, sometimes. There are very few of them who use a high percentage of recycled paper. Many of them are printed on new paper. Newspapers, old school newspapers, they are often printed on recycled paper. Toilet paper. You like recycled toilet paper? Fresh stuff? There is a difference in the quality, right? I mean, I don't want to get too far into the bathroom discussion, but there is a comfort difference between most recycled paper, toilet paper, and normal or new toilet paper. So, and the same for the newspapers. Like we know, like that paper usually rips quickly, and like it's a little more coarse-grained in structure. So what I want to lead you to is most of that recycling is actually downcycling. It leads to a product of a little less quality or of a different type of the same base material. So we're trying to say, oh, we're being so good at recycling. And I remember a couple of incidents in my private life. Like for a while I was really adamant about not throwing away any stuff, and like I went to this party and a lady tried to hand me like I asked her for water. And I was like pointing to the tap because we were standing in the kitchen, and she reaches down into the fridge and hands me that bottle of water, and I'm like, I was just gonna refill, and she's like, oh no. I'm like, no, stop. I want the glass of water. And she's opening the thing. She's like, oh, don't worry, I'll bring it to recycling later. I'm like, you did not get the point. Like, recycling the bottle doesn't make it go away that we're wasting it in the first place, and it's going to be downcycled into a product of lesser quality, if at all. So I don't want to talk down on recycling. It's good that we do it. I'm just saying it's not solving the problem. It's more kind of mitigating, making it less bad. Okay, so ideally what we'll be aiming towards is a cradle-to-cradle cycle. Have you heard of the term cradle-to-cradle? Who has heard of that before? Just the term. No. Okay, you have? You want to try and explain the rough idea what it is?
Can you give me a minute?
Okay, so cradle-to-cradle means when we start creating a product and then we go through the use, and then at the end of its lifespan, where I have used it for a while, it's going to be turned into something of equal value. So cradle to cradle means if I produce something, I sell it to you. At the end, when you're done with it, you bring it back to me, and I can remake it into something that is of equal value. Ideally, if I use a glass bottle and return it to the person who sold it to me, and they have the possibility to rinse it out really hot and sterilize it and everything, that thing, same value. until the day when somebody breaks it. Then, I don't know, then we have to go through more effort of melting it and making something out of it again. But the idea is when instead of doing this downcycling thing where we get less quality with every product cycle, we maintain that same level of quality. And that has been shown for a couple of little materials. So we've shown that for a certain composite plastic that we can use for instead of paper. There was a book called Cradle to Cradle that explains that approach really well that I've read a few years ago, and that was printed on that specific paper. And it was kind of interesting. It had a slightly plasticky feel to it. And he said, when you like are done with this book, we can kind of melt. It wasn't exactly melt, but kind of a similar chemical process. Like we can dissolve this and then make a new book out of it. And I thought that's a pretty cool idea. Now the problem with these like individual little solutions is that transition period. We still have thousands of books out there that do not use that same material, and there's maybe just a few thousand that have this composite material. So how likely is it to really get them back to the same place and go through that process? So what we would really need on that level, even if we were at the stage where we have figured out all the cradle-to-cradle approaches, you need to get things back to the source so they can do that. It's not going to be done with, we're going to put it in one of our 3 bins. Unfortunately, like that would require incredibly complex logistics to have somebody else sort out where all these things need to go. So despite the fact that I'm pretty excited about some of those partial solutions, I also know it's a long way to go to make that scale for everyone. However, there are also what I like to call the new hopes for solution. And those are the 3 words that we had on the outline where I said, maybe they can help us. And they are called decoupling, substitution, and dematerialization. We're going to look into each of those 3. And despite the fact that we will be talking about a lot of, it's looking pretty bleak out there and we really got to do something, this is to move you into action because I'm refusing to give up ever. I'm pretty optimistic when it comes to life. Don't know what the solution is going to be, but we're going to find it or it's going to find us. The way how it's going to find us, part of that goes into science fiction. So we won't talk about that within this class, but that would be the positive outlook of a solution finding us. But for now, we're on our own, as far as we know. So we got to do what we can. And 3 of those paths could include decoupling, substitution, and dematerialization. Now, before we get to that, I got to talk about one more knowledge term. Planned obsolescence. I already asked you at the beginning whether you heard of that term, and nobody, oh, you have, okay. So, Brian, how would you describe it?
So, I don't know if anyone's aware of recent scandal with Apple. So, their current thing is how Apple produces iPhones that will only last for a certain time period. Mm-hmm. So they know their product will only last for like maybe 3 generations down the line, and they'll know that it won't be supported after that. So in essence, Apple's creating products they know will deteriorate and people will buy new products. So they know these products have an end, and rather than these big companies producing items that will last in the long term, rather not do that to make more money.
Yes. So that is the general gist of planned obsolescence. We create a product with a specific lifespan in mind, and we're not really planning for making it last as long as it possibly could by hardware. We're making it last however long convenient for us and make sure that you buy another one down the road. Now that big technology company got into critique for that, but how long back do you think this idea goes? This idea existed way before technology. What's your guess for the earliest product where planned obsolescence came up? Adam?
Household appliances.
Household appliances, yes. So that also deals with electricity. I know that a certain printer company that I'm not going to name got into trouble for having a similar thing. They had a hardware counter inside their printer, and when that reached a certain number of pages, it would just generate random error messages. But before that, household appliances, yes. Are you thinking of a specific one, Adam?
I remember reading like that, like that's when they started doing it. I forget like.
Okay, so what's the earliest household appliance that you can think of? You walk into a house decades ago. Sorry.
The fridge.
Fridge. Yeah, fridge might be one. It was way earlier than the fridge. Ironing, yeah, maybe. Stove? Well, we can cook with fire as well, so I can't say earlier than that, but think a different route. So the first one, there were two first occurrences that I know of. One of them is with the use of electricity, and that is a light bulb. So what they did with the light bulbs was when they first manufactured them, it was, well, you could use it for lighting a room forever and ever and ever, ever, and that thing would just not burn out. So the company figured, we're not going to make any money with this if we only sell the product once and then customers happy till the end of their life. So better make that wire thinner so we only have a few thousand hours of light coming out of that thing, and then they have to buy a new one. So that's one of the instances. And then the other one, you don't need that as much in California, but nylon tights. So nylon tights came out at the beginning of the 20th century, if I remember correctly. And the first ones, they were like almost like good leggings. They would never break. And so they also figured out, well, we're never going to sell enough of this. We're going to make them thinner so they rip more. And that's what they pretty much do today. So not all of you may have their own experience with nylon tights, but pretty much every other pair you put on for the first time, you're like, oh, and there it's running already. And if not right away, then by the end of the night. So the products that are created in a way that they last for less than they would need to, a shorter than necessary lifespan for the sake of making profit. Now the question is, can you think of any way how we can decentivize that? How can we make sure companies don't do something like that? One thing is always legislation. Yeah, somebody finds out, we're going to sue you, or somebody else is going to make money. Definitely the attorneys. Brian?
You could probably do wallet. So it's as simple as not supporting that company and going for other competitors that do support your ideals, in a sense.
Okay, good one. So we now we're gonna stop buying any Apple products because they got busted. We know they're doing that thing, but who's gonna tell me that Samsung doesn't, and that Huawei doesn't, and that Ericsson doesn't, and all the other competitors don't do that? Same with the cars. So we know that, which German company was it got busted? Which German car producer for their emissions? No, Volkswagen. So Volkswagen got busted because they were falsifying records about their diesel emissions. So we're not going to buy any more Volkswagen. But who's going to tell me that the others don't do it just because they haven't got busted yet? So one part is, yes, I can vote with my wallet, but are there any other ways that I can make sure that the company that I do choose lives up to their ideals? What are things that we have put in place for that, or that we're trying to establish?
There's like a movement for freedom to repair products.
Yes. So there's a big movement for freedom to repair. So there's a grassroots movement by consumers who say, I don't want to do this. Like, I don't want to rely on your service personnel that then tells me my thing is broken and I better get a new one instead of like being able to fix it myself or at least try it. Story of me and this laptop. This laptop was not constructed for people to take it apart. But I was proud, like a 5-year-old in kindergarten, when I screwed it open, I like upgraded the hard drive, and over winter break, I replaced the battery. I'd gone to the App Store and they were like, me, they talk to service personnel, me, they have their own rules, and yeah, I can't do that without a technician. When I walk to the store, I'm like, hey, can I have a replacement battery? And they're like, yeah, no, you have to have a technician look at that. I'm like, I'm not interested in your technician. I have a screwdriver. I want a replacement battery. So I bought it off the internet. But different stories. So yes, there is this repair it yourself movement. Definitely. Some of the hardware vendors try to prevent that. Others are more for it. Big throwaway product, those phones. Who of you knows a vendor who facilitates repair it yourself, who allows for component replacement? None? That's the problem. So there are some people who are trying. There are some companies that really try for that. One of them is called Fairphone. Not because I want to advertise for them, but they are they're the one whose name I can remember right off the top of my head, who do first of all a sustainably resourced production, and then they also allow you to buy components, to buy parts. Are they at the same fancy technology standard like the latest products by the big vendors? Not quite. They're trying really hard, but it's hard to get up to that degree of sleekness and slimness if you want things to be replaceable and if you want your users to be able to work on them themselves. So there's a trade-off to be made here that many people are not willing to make. Also the monetary trade-off. A Fairphone may cost a little more, despite the fact that you don't get all the sleek and fanciest new user experience. But that's just something that everybody has to try for themselves. So now you know the concept of planned obsolescence. And it's, how about we make our product a little less good, but we can make more money off it because you have to replace it more often. All right, now back to the good news. Like, what the heck can we do about this? There is a grassroots repair-it-yourself movement. There are some companies that have decided we want more sustainably sourced products and we want users to be able to repair themselves if that is possible. Now, if we try to decouple, first magic term for this class, decoupling. Planned obsolescence was not so magic, that was me. But one of the solution paths could be decoupling. So is there any way how we can decouple GDP? GDP stands for? Yes, gross domestic product. How can we decouple that from resource extraction? We know people will want to earn more money. And we have proven that does not work as long as we rely on the resources that this planet has. That means we need to decouple that. We need to make it independent of one another. That way we can pretend we can always make more money, but it's not coupled to the natural resources anymore. I'm throwing the dependent there because I still have my reservations about that theory. But making it possible to create, say, a kind of services that has less material intensity, that is certainly leading us in the right direction. So the material intensity is the resource extraction that we need divided by the GDP. And that needs to go down over time. Otherwise, we're going to go down. Now, what resources are we even talking about? So all those three terms, decoupling, substitutability, and dematerialization, they go in kind of the same direction and they're related to each other. So decoupling was decouple economic growth from resources. The second one is how can we substitute some things? And for that, we have this little table to help us differentiate what types of materials are we even talking about? Like, what are things that are material? What are things that are immaterial? What is stuff that comes naturally out of the earth? And what is human-made? So for the natural materials, a renewable one is wood. Renewable because that forest will grow again if we give it enough time. Non-renewable are some of the minerals that come out of the earth. Because once we've extracted all of them, that's it, period. We're not growing any more new ones. Gotta call God and tell him to make another planet. And then would be like an ant colony just eating everything up like in Ender's Game. Who of you has seen Ender's Game? Read Ender's Game? Okay, read it. It's on your reading list for this semester. I think I have an entire list of really interesting science fiction books that illustrates what would happen if we took some of these principles to the extreme. I mean, that's how science fiction really came into being. Go look at an old science fiction movie from the 60s, it'll blow your mind. It's really interesting how far we've come, and sometimes in similar directions and sometimes in very different directions. And getting back to this year, what are some immaterial, natural resources that we have? The song of a bird, something I can listen to. It's something I can't grab. I can grab the poor bird. Don't. These are bird bees. There's information, there's genetic information. And then there is climate regulation. I'm not talking about a law, I'm talking about the climate regulating itself. Sometimes with not so great side effects for the human and for the animals. And then we have human-made materials. We've certainly successfully built a ton of machines. We have built environments, the buildings that we live in and that we work in. And we have engineered materials, composite materials, aluminum, all those kind of things. And then we have immaterial stuff. We have created literature. We have created scientific knowledge. We have created algorithms. Well, what do we take away from all this? When we have innovation going on, when we invent new technology, then that may in part be able to replace some of our older technology. And hopefully, that will help us substitute some of the things that we do that are more resource intensive. Now, when you bring a bunch of sustainability researchers into one room, it will have a very lively discussion with a lot of controversy around how much do they think we can really substitute in the future? What are examples that you can think of where we could potentially substitute something? When you think of the old ways, like something we're doing now, or something that we used to do a couple of decades ago compared to how we do it now, where have we substituted things? And I'm not saying that substitution needs to be the perfect solution now, but where have we substituted things? Adam?
Like coal and gas.
Yes, we have substituted, wait, in which way? We still get a lot of our electricity out of coal and gas.
Yeah, well, I mean, we get some of it from like wind and hydropower.
Okay,
It's not
so,
completely substituted, but it's getting there.
got it, okay, because you could read that in two different ways. We could say, I now have an electric heater, I used to burn coal in my oven. So that would be one step of substitution. And then the next step of substitution is, well, if I already have electricity, where do I get it from? We used to get it from fossil fuels mainly. And now we also have some renewable energy like wind and water. Yes, absolutely. What else? Who of you works from home? Has a job where you can work from home partially? What enables you being able to work from home? Yeah, computer. So we have mobile machines, we have laptops that we can just take from work to home. All the stuff is on there. We have an internet connection that allows us to work from home, which is saving you the commute in that case. So maybe you're using an internet connection instead of spending a few gallons of gasoline on the road. Downside of that, communication may not be as immediate with your colleagues. It's a slightly disconnected feel. You may be getting a lot of things done at home because you're not disturbed by colleagues. But then again, laundry needs to be done. And, oh, what was left in the fridge? So there are some things that these substitutions often improve. they also usually come at a cost of something else. Like we often talk about this for research conferences. Yeah, definitely blows a ton of emissions in the air if I go fly to a conference. But I also know the work that we do there together is going to be so much more productive than if everybody of us was sitting in front of their laptop just looking at a screen and then falling asleep at the second presentation because I'm alone in my office. So there is a trade-off for any of these substitutions, but we need to think about them. So, for definitions, today's the day of definitions. Substitutability means if a function provided by a system can also be provided by a different system, a substitution system, so to speak, then we have a substitutable system, S'(4S), if it performs that same function F. Now, if we try to use that on the example we just talked about with telework, yes, it enables us to like send emails, work on a PowerPoint presentation, do some spreadsheets, same as if we were in the office. So in that regard, that system telework is perfectly substitutable for work in office, but not necessarily with all the functions we associate with work. So for that partial part, yes, absolutely. For the important conversations that happen around the coffee maker, when we really talk about the problems that are going on behind the scene, those are more effectively solved in an office, usually. Depends on the communication culture. Now, when we talk about where does it make sense to substitute, then we want to most look at the non-renewable resources. So anything that will help us blow less emissions in the air is certainly worth a second thought. And then if we were really optimistic technologically, then we could do that with all of the natural resources. We're just not gonna leave our homes anymore. We don't have to drive around in cars, or we can just take the new Hyperloop. And that way, not a problem, right? If we're not quite as optimistic, if we think more precautionary, then we know we should probably not only think about the non-renewable resources, but also about the renewable resources. Because when I chop down a forest, I may be able to regrow that forest in 30 years. But maybe the forest I chopped down had the last exemplars of a certain species of animals. They lost their home now, they're gonna die. They're not gonna wait around 30 years for another forest to be grown because they won't survive those 30 years. So there may be some irreplaceable properties around a system that we're using that we just didn't take into account. Those are the two extremes. Most people range somewhere in the middle of that. So substitution, good thing in general, but also we need to think really hard about it when it's the best way to go. Now, in which way can we think about it? Well, back to some of the work of Lawrence Hilty. This is directly taken from one of his slides at a keynote in Stockholm from 2014, where he was using that example. There is an intercontinental meeting. Bob and May would like to meet, and we can look at different examples of where we can substitute part of the resources that they would be spending on their intercontinental meeting. So they can just use an aircraft. Okay, and then that aircraft it needs an airport to fly out of and to fly into. It needs crew. We have the aircraft itself that requires to be built by an aircraft industry, and it uses a bunch of fuel. Fuel comes out of a refinery. Refinery extracts natural resources from an oil field. The fuel will also go into the atmosphere as a sink for the CO2 emissions. The aircraft industry needs workers, needs material supply. The workers need food and water, which comes out of an ecosystem. The workers need air, same ecosystem. And then the material supply that we get for the different parts of the airplane, they will also be supplied by some raw materials like minerals that we need to resource from the earth. So far, this is a little portion of a resource tree. Now the question is, if we start thinking about where we can replace some of these parts, we can do that on different levels. So first of all, we could say intercontinental meeting. Nah, they can Skype. People of you who've ever been in a long distance relationship, you know it's not quite a replacement. Physical transport. Maybe there's a transcontinental vacuum train under the big pond. Maybe instead of a conventional airline, we can use a super efficient aircraft. Maybe the conventional aircraft can at least use green fuel, whatever that is. So maybe some kind of replacement fuel, some biofuel. Maybe if we still need to use conventional fuel, then we could at least use a CO2 sequestration system so the emissions are not as harmful. So we can find substitutions at pretty much any of these levels, and the trade-offs are going to be different. So with this one, if we replace it down here, we still have most of the resources that go into this entire spiel, from the aircraft industry that needs to build the thing to the airports that are needed. But in that direction, we have a decrease in the quality of the interaction that those people can have in their meeting. So a bunch of questions that come out of that. So how willing are airlines to even consider some of these things? Because an airline is a company, they need to make money. Here's again that ever persisting trade-off between how do we make sure everybody can be okay and at the same time not screw up the planet completely. And down here, what will climate activists go, this one is a little far-fetched. What will climate activists do if they're going to lose their problem? I'm pretty sure we have enough problems to solve to keep every climate activist busy for quite a while. But down here, let's get rid of conventional fuel. We have thousands of people, millions of people working in the oil industry. They're all going to be out of a job. Me, I don't really like to count that one because we've gotten rid of industries before. What about the good old times when we used to have messengers riding horses? They're all out of a job now, but they all found something else. The old landline telephones are hardly in use anymore outside of companies. Like, most of my friends don't even have a landline anymore. Just everybody has their cell phone. And a lot of companies do the same thing. Oh yeah, we live in a place like we don't have landlines anymore. Everybody has a cell phone. So nobody's ever in their office anyways. So I don't think that the fact that we need to change things, again, think back to Monday, we thought death and taxes are certain. I'm not so sure of that anymore. The only thing that I know is going to persist is change. So we will have to be okay with things changing a lot, with losing certain industries, with finding different ways of doing something. All right. That was certainly enough download. Let's digest this a little. I have a little thought game for you. So think about two pens. There is a really nice, fancy fountain pen. It's made from platinum, costs about $200. And then there's a second pen. It's a cardboard ball pen made out of recycled material. Costs about €1, $1, same. Which pen do you think is the more sustainable one? Take a minute, talk to your neighbor, have a discussion about which one could be the more sustainable one. All right, let's bring it back. What do you think? What are your thoughts? Which pen is the more sustainable one? Who would vote for the fountain pen? And who would vote for the cardboard pen? Let's try this again. It cannot be that 70% of you cannot decide. Everybody needs to raise their arm for one or the other. You can change your mind later. It's okay. So who would, for now, go with the cardboard pen? Who would, for now, go with the fountain pen? Okay, that's very interesting. Why would you go for the fountain pen? It lasts forever. Yeah. Mm-hmm. Yeah. I have one of these guys. That one. Gonna last forever, I hope. But so you kind of screw with my exercise for a little, because most of the time people first go for that one. Also depends a little on what kind of a person you are. If you always forget your pens in all places, then maybe you should go with that one, because you cannot afford this one the 5th time you lost it. If that one has gnarly plastic cartridges that you need to replace every 2 weeks, that's also not very sustainable. But most of the more expensive ones, they have one of these tanks that you can refill. This one's empty, pretty empty. I'm not so sure about replacement cartridges for that. They would probably be more expensive than the cardboard case. So you would probably throw that one away and buy a new one. So I found a lot of these laying around in all sorts of conference places, whereas I haven't found many fountain pens laying around. So you do tend to pay better attention to a product that you own that is high quality. Yes. And then granted, there's probably a certain meaning to a pen like this. I have to say that pen actually at the beginning was not very sustainable, because it was laying in my desk drawer for about 5 years. Because I was like, oh, it's such a pretty fountain pen, and my dad gave it to me, and I don't want to lose it, I don't want to scratch it. And then at some point I looked at it and I was like, you're never going to make it out of that drawer if I don't start dragging you around. So I've been dragging that thing all over the planet by now, and it's thoroughly scratched up, but it still writes pretty well. And every time I write with it, I'm happy, because it makes me think of my dad who gave it to me. So you were already pretty good in like looking a little further ahead. It's going to last you longer. And it's also about the habits that we have with working with a specific part. What we did not talk about right now is the resources that go into the production of either one of those pens. Because apart from this one costing a lot more, it was also way more complex to manufacture. But we can probably outweigh that with a very long period of usage. All right, I would say it's time for a break. Thank you so far. We'll get back here in 10 minutes.